hyperbolas. We are going to start hyperbolas on page 13, which is a graph paper page, but we're not really using it necessarily for graphing. There's going to be some information about the definition of a hyperbola and the title, and then the bottom 3/4 of the page, or the bottom half if you write smaller, is going to be about a horizontal hyperbola. And then on page 14, right next to it, we're going to write the information about a hyperbola with a vertical transverse axis and some other information about the equation. So kind of similar to what we did for the ellipse setup, but this is starting on page 13. All right, so on page 13, we first want to write down the definition. So a set of all points P such that the difference of the distance between the foci and P is constant. And we talked about what this means, so it would probably be nice to draw a little picture for you guys. Just a little sketch of the hyperbola. Remember, this has been the top quarter or top half of page 13, where we have our vertex points, we have our focus points, and we have an understanding that to build any point P on this parabola, we have a couple of different distances here. Oops. There we go. Sorry, don't connect it to the vertex. It should be connected to the focus because that's what we base this definition on. And it basically says that when you subtract those two distances, you get a constant number. Similar to the ellipse, but for the ellipse, it's the sum of the distances. So for a hyperbola with a horizontal transverse axis. So what I did is I just put the horizontal equation on page 13 and the diagram, and this other information over here about the equation, okay, that stuff, I put that on page 14 with the diagram because I had more space that way. But, you know, it's totally up to you. So a horizontal transverse axis just kind of means that the branches of the hyperbola are horizontal. So having a horizontal transverse axis means I expect there to be some center, and then from that center, some vertex points. And then also, like we saw, some focus points. And how we get these distances we'll talk about in a little bit. And the branches of the hyperbola will go through the vertex points, okay, and wrap around the focus points. Now, what's not listed here is that we also have some asymptotes, like some people had brought up in class. So there actually are some guiding lines going through the center here, kind of dictating that the curve won't go any wider than this boundary, this asymptote. Okay, so there are our asymptotes. Now, A and C are distances that you're used to. A is the distance from the center to the vertex, and C is the distance from the center to the focus. So where B comes into play in this case is that B actually makes for us a point to help guide our asymptotes. So when we build these asymptotes, we're using the center as a guide point, and we kind of use a slope from there. So we use the center point as a point on our asymptote line, and then we need a slope, a rise and a run, okay, to get another point and to be able to completely draw this asymptote. So our run, this part right here, is that A distance from the center to the vertex. So it's the same as this distance we saw down here. How to know how much to rise depends on the B value from the equation. So it's kind of like the ellipse, that whichever distance you go from the center to get the vertex, like if you move left and right, then to get these other points you move up and down. But we don't call them co-vertex points because they don't actually form anything on our ellipse. But what they do give us are the asymptotes. They call this axis running through the hyperbola the transverse axis. And if you looked kind of where it's symmetrical about, like if you ran an axis down through the center the other directions, perpendicular to the transverse axis, that would be called the conjugate axis. We also have our asymptotes. And depending on where the hyperbola is located, the equation of the asymptote is going to change. It's always going to be a linear equation like a y equals mx plus b or something like this, but it's going to depend on that center point and the slope. But you can clearly see that the slope is always going to be, in this case, rise over run, which is b over a, and the slope of the other asymptote is going to be negative b over a. So the asymptotes are always plus and minus, and in this case, the b value over the a value. Okay. Then we're going to look at the other case. Now notice how to differentiate a horizontal transverse axis ellipse from a vertical one. When you look at the equation, notice here, it's going to be a little different from an ellipse because a is not always going to be bigger than b. You just don't know. It could work out either way. So identifying the larger number doesn't help us here. But notice here that the x term in the equation is positive, but the y term in the equation is negative. That is how we differentiate in this case. So notice when I get to the vertical one, the y term is positive and the x term is negative, but a and b haven't changed. So a squared is always underneath the positive term in this case. It has nothing to do with what's larger because the distance to the vertex here is not the biggest thing. Secondly, the positive term tells you orientation. So I now know that I have a center, I have vertex points. Okay. We would have our hyperbola going through those vertex points and wrapping around some focus. And the same thing on the other side. And we know this also means that we have some different asymptotes and stuff running through here. So we have A as our distance from center to vertex. C is our distance from center to focus. And we know that going through the center, we have these guidelines for our curves, these asymptotes. Okay, so we have our vertical, transverse axis, hyperbola. We have our vertices, our focus. We were talking about the asymptotes here. Also remember again that the axis going through the parabola, this is called the transverse axis. And if we drew an axis perpendicular to that going through the center, we would call that the conjugate axis. And again, we were talking about our asymptotes and about how we derive those or get those from looking at numbers on the equation, and that b value actually indicates the slope. So from the center, okay, we rose some amount, which here is clearly a because we're going up from there to there, and we run some amount to find another point along the asymptote, and that run distance here is going to be b. Okay, so here the slopes of our asymptote, the rise is a and the run is b, so it's a over b, and for the other asymptote, negative a over b. That's not the equation of the asymptote. The equation of the asymptote would be the equation of the line that has that slope and passes through the center point, but at least we know the slopes of the asymptotes. Now we're going to try and take all this information and do some examples with it. So your pages 13 and 14 should be filled with this information about equations and what each thing represents. So on page 15, just to give you an idea, we are going to do two graphs. So I would basically put example 1 in the top half of the page to graph and example 2 in the bottom half of the page to graph. Example 2 has a little more work with the equation, so if you're worried about spacing, that could be helpful. All right, so example 1, we have an equation. I identify that it is a hyperbola because it has a negative term and a positive term, and this is already in the standard form. Now remember with the hyperbola, a squared here is 20. It's not about what number's bigger, okay? So when I look at this, here's what I know so far. And pay close attention. Look at which term is positive and which term is negative. So here, they're not written in the order you might be used to seeing them. X is actually the second completed square, has the negative in front of it. Make sure you pull your H and your K out of the correct spots. So here H is 1, K is negative 3. That's my center. I expect this hyperbola, since the positive term is underneath, or the positive term, is with the y, I expect it to have a vertical transverse axis. In other words, I expect up and downward facing branches of my hyperbola. So I have my center at 1, -3. From the numbers that are up there, a squared is 20, b squared is 25, and that means that c squared, which is going to equal a squared plus b squared now, it's going to be 20 plus 25, so c squared is going to be 45. So what this means for some of the distances that I'm dealing with is that I expect a to be about the square root of 20. It is equal to the square root of 20, which is about, okay? Well, it's more than 4 because the square root of 16 would be 4, but less than 5 because the square root of 25 would be 5, and just slightly closer to 4, so maybe it's like 4.4. And b squared is equal to 25, which means b is equal to 5. C squared is equal to 45, which means c is equal to the square root of 45, which is about, let's see, the square root of 36 would be 6. The square root of 49 would be 7. So it's between 6 and 7. It's closer to 7, so I'll say like 6.8 or something like this. All right, so I'm going to put my center at 1, -3. I am going to put my vertex points 4.4 units away from the center vertically. This is my a value, and based on how I expect this to turn out. So 1, 2, 3, 4.4. 2, 3, 4.4 below. So those are my vertex points. And so again, if I wanted to record what the coordinates are of these points, the x-coordinate stayed the same as the center, and the y-coordinate changed by an increase of 4.4 and a decrease of 4.4. So -7.4 would be decreasing at 4.4, and then positive 1.4 would be increasing at 4.4. Now, we want the asymptotes to guide the branches of our hyperbola. And what we know about the asymptotes is that they are lines that go through the center and have a slope that's related to a over b or b over a. In this case, you can see that from the center to the vertex is a rise measurement. So a is going to be our rise, and b is going to be our run. Okay? So my slope of my asymptotes is going to be 1 positive and 1 negative, and it's going to be 4.4, or the square root of 20 over 5. Okay? Or if you simplified this in radical form, because it's weird to write a decimal in a fraction, we would have 2 rad 5 over 5. Okay? That form doesn't really help me. What I'm thinking in my head is that the slope is a rise of 4.4 and a run of 5. So I already have the amount that's gone up 4.4, and I'm going to draw this so you can see it in orange, and then I'm going to erase it. Up 4.4, and then I would go over 5. 1, 2, 3, 4, 5. So over to there. Okay. So another way that people often do this is they create this rectangle. So to get to that point, I'm going to show you something people often do so they don't lose track and they can draw all the asymptotes at once. So what they do is they say, just like vertices and co-vertices in an ellipse, we went up and down to get our vertex points. So they say, let's go right and left the other distance to get our co-vertex points. 1, 2, 3, 4, 5. So that would be out here. 1, 2, 3, 4, 5, and out here. Now those points have nothing to do with our hyperbola, but they do help with the slope of our asymptotes. So what we can do to get all the points for all the asymptotes kind of quickly is we can create this little rectangle, because what it does is it shows us the points our asymptotes are going to cross through besides just this center. So one of our asymptotes is going to go through like this. and the other asymptote through this corner of the rectangle, through the center, and the other corner. Because the corners of the rectangle represent where you would be if you use the rise and the run from the center. Okay. So then I know here that my branches of my hyperbola go through my vertex, and they kind of use those asymptotes as a guide. So I'm going to go ahead and go like this. And then I need to put my focus points on the graph, which I know should be further from the center than my vertex. I'm going to use this distance of 6.8. Okay. So remember, they're going the same direction as the vertex, so vertically, so they're going to have the same x-coordinate as the center, and then it's going to be an increase of 6.8 and a decrease of 6.8 from the center. So that's going to be at negative 9.8, and then at positive 3.8. 4, 5, 6.8, and 1, 2, 3, 4, 5, 6.8. So there's my focus points. Okay. So you're going to want to include slopes of your asymptotes, focus points, vertex points, and center as important information for your hyperbola. All right. So the next example we're going to look at goes in the bottom half of the page. You'll see this is going to take a little more work ahead of time because the equation's not in the proper form. Now, we have the equation written. I can tell it's a hyperbola because one term is negative. So right now it appears that the y is positive. So I'm going to put y squared minus 2y. Those are going to help me form one group. Then I'm going to factor the negative and the coefficient out of the terms with x. So that's going to be negative 4 times x squared plus 4x. This 4x right here, you guys, is from the negative 16x after I've factored out a negative 4. And then I'm going to move the 1 to the other side of the equation so it'll look like negative 1. I'm going to go ahead and complete the square. So add 1 here, and here I'm going to add 4. And so I've added 1, and this 4 is really like a minus 16. So I've added 1 and a minus 16. So what I have here is y minus 1 squared minus 4 times x plus 2 squared equals negative 16. Now a hyperbola, just like an ellipse, we would like the equation to be set equal to 1 if we want to see those important values in the right place in our equation, the a and the b and stuff. So I'm going to divide everything by negative 16. Oops, sorry about that. So I have 1 on the right side. Then on the left side, I have y minus 1 squared over 16, but that term is negative. And then I have x plus 2 squared over 4, and that term is now positive. Okay? So if you wanted to write this with the positive term first, you would have x plus 2 squared over 4 minus y minus 1 squared over 16. You don't need to write it with the positive term first. It's just how it was written on earlier slides so that you could see it that way. So remember, our a squared has to do with the positive term of the hyperbola, and the fact that that positive term has the variable x tells me my expectation is a horizontal transverse axis. Okay? And I know from here that if a squared is 4, then a is 2. B squared is 16, so b is 4. And then remember that our c squared can be found with a squared plus b squared. Okay? So it's going to be 16 plus 4 is going to be 20. So c is going to equal the square root of 20, which we already went through, approximately like 4.4 or something like that. So all of this information I'm going to try to put on my graph and record what I need to know. So from my equation, my center, my h and my k values would be negative 2, 1. Let's see. So my center is negative 2, 1. I'm going to go ahead and plot that negative 2, 1. My vertices are a horizontal distance away from the center, and my vertices are based on the a value, so they're 2 units away from the center. And that would make the points the same y-coordinate because I haven't changed the height, but 2 units away from -2. So -4 and 0. Now I want to go ahead and put in my asymptotes so I know how wide to draw my curve. And like we talked about before, kind of a way we can quickly get all the points for all the asymptotes is to use our b value and go that distance of 4 like as if we were making an ellipse with co-vertices out in this other direction. We don't need to label those points. We're just going to use them to give us a picture of where our asymptotes go. So they go through corner, center, corner. And same thing on the other side. Corner, center, corner. Okay. And now I can see that if I draw a curve the correct direction and through the vertex points, I can follow the asymptotes to kind of get an idea of the width of that curve. The other thing I want to do is I want to graph my focus points. Which again line up horizontally in this case with the center and the vertex, so the y-coordinate is not going to change. But the x-coordinate is going to change by a distance of 4.4. So I'm going to take this -2, I'm going to increase it by 4.4, which will put it at 2.4. And I'm going to decrease it by 4.4, which puts it at -6.4. So at -6.4, and all right, so we have our center, our vertices, our foci labeled. We have our picture of our parabola, and we would want to mention the slopes of the asymptotes. And we'll talk a little bit more in class about how we could actually write the entire equation of the line with the asymptotes. It's a good algebra review. Our slopes are plus or minus. And in this case, the b distance was the rise, and the a distance was the run. So in this case, it would be plus or minus 4/2, which is plus or minus 2. So that information was all on page 15. On page 16, we're going to fit 3 examples, but they're writing equations, so it's a little bit shorter, but just split page 16 into 3. Okay, so like we said, on to page 16 to do 3 examples with equations. So you'll just have it in thirds. Like each example might take a third of the page, maybe not even that much. Okay, so we're going to write an equation of a hyperbola, and they tell us the foci and the vertices. So let's think about what this means. Sorry, I'm going to put it right here. Okay, so foci at 0 plus or minus 5. So that means there's a focus here at 0, 5. There's a focus here at 0, -5. And there's a vertex here at 0, 2. Oops, what am I doing? There's a vertex here at 0, 2, and a vertex here at 0, -2. So clearly the center, whether you do it from the vertices or from the focus points, needs to be here at 0, 0. So 0, 0 is my center. And because the vertex and the focus are lined up the way they are, I know that the hyperbola would have this vertical transverse axis, which means I expect the y-squared term to be the positive term. Now I need to think about EA and B. So here is my A distance from the center to the vertex, where A is 2. Okay, and that is a vertical distance, so that's going to go underneath the y-squared term. I don't know anything about B. I do know the C distance here from the focus to the center, that C is 5. So I'm going to use C squared equals A squared plus B squared. So C squared would be 25. A squared would be 4. And so B squared is going to be 21, and that's going to fill that spot of my equation. For the second example on this page, where we're going to be given stuff that's not all around the origin, I can tell. So we have a vertex at 2, 4. So here's a vertex at 2, 4. I have a focus at 4, 4. Well, I guess I shouldn't have written that there. So I have a focus at 4, 4. And a center at negative 1, 4. So I can tell that this is going to be horizontally oriented. So x squared is the positive term, but it's not x squared. Sorry, because we do have a center here. So it's x plus 1 squared because of the negative 1 in the center, minus y minus 4 squared because of the 4 in the center. The a value, the distance from the center to the vertex from negative 1 to positive 2 is 3 units. So the a value is 3, so a squared will be 9. And then the b value. So again, I don't know, but I do know this distance here from center to the focus is 5 units. And so that's my c value. So using c squared equals a squared plus b squared, I have 25 equals 9 plus b squared. So b squared is going to be equal to 16. All right. And our last example. So we're told where the two foci are. So at 1, 7 and at 1, negative 3. And so that tells me there's vertices somewhere, and my hyperbola is going like that. So I know it's vertical. I can also find the center between these two, because the center is going to have to be some point that is exactly in the middle here. So it's going to have an x-coordinate of 1, and then exactly between 7 and negative 3, if we add them together and divide by 2, that will give me 2. So the center is at the point 1, 2. So I'm going to have y minus 2 squared. It's minus. And then my second term is going to have an x minus 1 squared. For the a and b values, I don't know. Let's see. I have the slopes of my asymptotes here, and they're listed as 3 over 2. So think about what that is here. There are some asymptotes here through the center that have a slope of 3 over 2. Remember what we talked about. That means from the center, there's a rise and a run to get to another point on that asymptote, and they're telling us the rise is 3 and the run is 2. So 3 is our a, because that's the distance to the vertex, so a squared would be 9. And 2 is our b, because that goes in the other direction, so b squared will be 4. Okay? So if you need to go back and look at anything, do so, and I will see you guys tomorrow to work on our hyperbola homework.